All right. Let's refresh our memory. In the previous example, we have to factor ax plus 5x. So we want to make it becomes something times something. So first we need to take a look at the GCF, and the GCF in this case would be x. And once we factor out the x, the leftover would be the original terms divided by the GCF. So in this case, we have a left over plus 5x divided by x. So we have 5 left over. Okay. What about if I want to factor out this thingy? I have 8 times parenthesis x plus 9 plus 5 times x plus 9. How many terms do we have here? We have 2 terms, separated by the plus in the middle, separated by this plus. So, in these 2 terms, do they have anything in common? I have x plus 9 in common. This is just like the previous problem. X can be anything. So once we identify both terms has these common factor x plus 9, I could factor out the x plus 9. So the leftover will be a plus 5. So that becomes x plus 9 times a plus 5. Now again, don't say x plus 9a plus 5 like that. You have to mention the operator in between. Just like when you have a plus 5, you need to say plus. You don't say a5. How about this time? I want to factor x times y minus 9 minus 5 times y minus 9. How many terms do we have? We have 2 terms again, separated by the minus. In these 2 terms, what do they have in common? Y minus 9. So I'm going to factor out the y minus 9. And so the leftover in the first term will be x. And the leftover in the second term will be 5. So turn out it will become y minus 9 times x minus 5. So far so good, right? Instead of the common factor x, well, this time we have a parenthesis, y minus 9 as the common factor. For this one, how many terms do we have? How many terms do we have? We have how many terms? 2 terms separated by this minus. This is one whole terms, 7x times something. So it's together. And for this one, we have another terms. So in these 2 terms, what do they have in common? We have x plus y in common. So I'm going to factor out the x plus y. And for the first term, what is the leftover? 7x. Minus, for the second term, what is the leftover? Is 1. Now remember, the leftover will be the original terms divided by the GCF. Okay? So try to help yourself. Don't say take out. Very often students say, oh, take out the common factor. So when you take it out, oh, you got nothing left, because take out is an ambiguous terminology. Take a look at this one. How many terms do we have? We have 1 terms? We have 2 terms? Or we have 3 terms? We have 3 terms this time. Terms are separated by a plus or minus. This is 1 term. this is another term, and this is the third term. Now, if I take a look at these three terms, I have 1, I have 5x, I have 6x squared times 5x minus 1. There will be no common factor because the last term is just 1. So, looks like nothing we can do. But, how about if I group the last two terms together? I put a parenthesis around the last two terms. So, how many terms do we have now? We have 2 terms. And in these 2 terms, do we have anything in common? Yes, we have 5x minus 1. So turn out it would be just like before. Once I factor out 5x minus 1, what would be the leftover? 6x squared and then plus 1. So far so good? Okay. So let's take a look at something a little bit fun now. Let's see. I want to factor by grouping this time. So the question clearly telling you to do it by grouping. You will have no other choice. You have to do that by grouping. You cannot just close your eyes, trust your feeling, and use some other force and then get the answer. You have to do it by grouping because they give you a clear instruction. How many terms do we have? We have 4 terms. Separated by the plus, we have 3 plus, right? So how can I do that by grouping? Now, this is how that works. Let's group the first 2 terms together. And then let's group the last 2 terms together. Because it just happened they have 4 terms, right? Once I group the first 2 terms together, I'm going to take a look. Hey, in the first group, do they have anything in common? X would be in common. So I'm going to factor out the x from the first group. So what is the leftover? X plus 2. Now by this time, you should know it very well how to factor a simple expression. Okay? You probably, at this time, you really don't bother to write down x squared divided by x plus 2x divided by x like that. But somewhere in your notes, especially in the period section, you should have those so that you can remind yourself when you review it, you know, oh, this is how we should factor out a simple expression. From the second group, what do they have in common? 4. I factor out the 4, and the leftover would be x plus 2. And now it go back to what we had before. We have 2 terms, and in these 2 terms, what do they have in common? X plus 2. So I factor out the x plus 2, and the leftover would be x plus 4. So finally, it would become x plus 2 times x plus 4. Not too bad, right? Let's see this one. How many terms do we have? 4 terms. In this case, they didn't even say any specific instruction. So maybe you might be able to do any way that you like. However, when you have 4 terms like this, they are completely unlike. Indeed, you will have to do that by grouping, even though they don't say that this would be the best choice. So let's see how are we going to do that. We group the first 2 terms together, plus, and then group the last 2 terms together. In the first group, what do we have in common? X squared. So I factor out the x squared, and then I have x minus 2 left. Plus, in the second group, I factor out the 5. So I have 5 times x minus 2. So once again, I have 2 terms. And in these 2 terms, I have x minus 2 as the common factor. So I further factor out the x minus 2. That will give me x minus 2 times x squared plus 5. So far so good, right? Let's see another one. I want to factor out this 4 terms again. Although the question didn't ask us to do that by grouping, but indeed, that would be the best way. 4 terms, they are completely unlike, and that is the only choice that we can consider. We group the first 2 pairs, the first 2 terms together, and then group the last 2 terms together. And then in the first group, what do they have in common? X would be in common. So I factor out the x. I got x times y minus 5. Plus, from the second group, what do they have in common? 9 would be in common. So I factor out the 9. I got 9 times y minus 5. So now go back. I have 2 groups. And in these 2 groups, I have y minus 5 in common. So factor that out. The leftover would be x plus 9. So finally, I have y minus 5 times x plus 9. Now, before I move on, let me just mention, when you group the first 2 terms and group the last 2 terms together, make sure you group it like that. And then when you group the second term, be sure this is a plus. And then you parenthesis is after the plus, not before this. Sometimes some students just kind of group them together. Or even worse is put a circle around something. Oh, I know what I'm doing, you know. Well, you have to do that in a proper way so that others people can understand. So common notation is absolutely important. When you group them together, this is just like you're adding 2 polynomials together. If you put the parenthesis before the plus sign, what would that becomes? You make it becomes a multiplication of 2 binomial. And even though later on you got the answer correct, that would be even worse because you will confuse, oh, whenever I see 2 binomial times together, that is what I should do. That's why students later on confuse. So set up a good habit is absolutely important. Don't do it in the wrong way, even though you got the right answer. Never just focusing on the answer. How about this one? They're clearly telling you to do that by grouping. So we have no choice. So I am going to group the first 2 terms together. Minus, and then open parenthesis, 5x minus 15. Is that right? Something wrong here. Say again? Negative 5x. Well, you mean minus open parenthesis negative 5x? So what do you mean? Okay. Any suggestions? Yes, the lady. Yeah. Okay, it would be plus 15. Now that one is a little bit interesting. Unlike all these previous example, if you take a look at the third terms, it's always plus something, plus 4x, plus 5x, plus 9y. So when you group the last two terms together, that has no problem. Now that is just like when you're adding two polynomials together. If the third term is a plus, right? If we're going backward, you can just remove the parentheses without any problem. So you go back to the original question. But in this case, the third term is minus 5x. So once you group the last two terms together, you must change sign. Now that is like when we subtract two polynomials together. And if I have the polynomials like that, and I have a first polynomial minus the second polynomial, the first parenthesis, I can just remove it. So we go back to x squared plus 3x. The second parenthesis, once I remove that, I must change sign. Remember that? So that will go back to the negative 5x minus 15. So the other way around, if the third term is minus, when you group the last two terms together, remember to change sign. So after that, we will factor out the x, and then I got x plus 3 left, minus, from the second group, 5x plus 15. What will be the common factor? 5. We factor out the 5, and so we have x plus 3 left. And finally, we factor out the x plus 3. So we have x minus 5 left. So the final answer would be x plus 3 times x minus 5. Let's try one more, and then we will have the dance. 4 terms again, but these 4 terms are completely unlike. So we will have no choice but to factor by grouping. Group the first 2 terms together and group the last 2 terms together. But once again, because the third term is minus, so once I group the last 2 terms together, I will need to change sign. And then I factor out the x, so I got x times y plus 1 minus 5 times y plus 1. So finally, I have 2 terms, and in these 2 terms, I have y plus 1 as the common factor. So I factor out y plus 1. That will give me y plus 1 times x minus 5. So far so good. Okay. All right.